One of the places that has been shown to be warming faster than anywhere else on Earth is the Arctic.
Given the recent loss of Arctic ice in 2007, which was unprecedented, it's a fortuitous time for us to be here looking at climate change in the Arctic. We're particularly interested in the atmospheric contribution to that.
There's a lot of pollution that is transported there. So our main goal is to see how it is getting transported, where it is coming from, and what impact it might have to the regional climate in the Arctic, which is also climatologically a very sensitive region of the Earth.
The Tropospheric chemistry program has flown these airborne missions for many years now, really 2 decades. But what brings us to the Arctic at this time is the International Polar Year.
ARCTAS itself is the most ambitious airborne sampling that NASA has ever done, but we're also collaborating closely with the International Polar Cat Campaign, and they will be bringing a whole lot of other international players to the party, including our colleagues from the U.S.
We are putting together an international group to really study this system using all of NASA assets, aircraft, satellites, models, everything we've got to perform a really detailed and intensive study in the Arctic.
So in the spring, we're looking at what's traditionally been described as Arctic haze. And this Arctic haze has components that come from pollution transport from mid-latitude locations. North America, Europe, Asia, Siberia, all those locations, all lending some portion of what's found up here in the Arctic this time of year.
One question is, how did it get to the Arctic in the first place, and then what happens to it after it's there?
One of the more unique things about the Arctic chemically is that unlike other parts of the world where you have what we call a diurnal cycle, the sun rises and sun sets, in the Arctic you have a much longer time span over which you have a dark period in the winter and then the sun rises in the spring. During the winter, many things can be transported to the Arctic, but they sort of sit and wait chemically for the sun to come. And since sunlight is the main driver of chemistry in the atmosphere, that becomes an important period to observe.
There's also speculation that the dirt and the black carbon that is in Arctic haze that's deposited just as the sun is coming up may actually change the albedo of the snow and hasten the melt season. As the Arctic warms, it's going to impact how the atmosphere is functioning, but there are a lot of reasons to think that changes in the atmosphere are contributing or forcing the Arctic warming.
We're not only looking at CO2, but clearly methane and CFCs and ozone, even more importantly, ozone being a greenhouse gas that's not emitted by pollution, but it's created through the chemistry of pollutants as they're transported to the Arctic.
In the summer campaign, we are going to be looking particularly at what gets produced by forest fires.
Over the past several decades, the intensity and frequency of boreal fire season has increased. And there are a lot of questions about whether there are feedbacks associated with climate in that increased intensity of fires.
We will also be measuring a lot of aerosols and particles and their composition.
What's of particular interest for us are the impact of those aerosols on radiation in the atmosphere. Do they reflect sunlight away from the Earth? Do they absorb sunlight and cause warming in the atmosphere? Do they cause warming in the atmosphere at a level above the Earth and actually then, as a result, cause cooling at the surface?
It is true that while we're up here, compared to other places, it does look very clean. But at the same time, with sensitive enough instrumentation, you can show clear signatures of impacts that can be explained by local conditions. So there is clear evidence of that pollution.
Pollution is a transnational issue, that everybody lives downstream of somebody else. And certainly that is tied up with many of these pollutants are also greenhouse gases or climate forcers. And so the Arctic is a very sensitive indicator of how interconnected the Earth is and how our activities are impacting it.
Given the fact that the pollution is so far away and so distributed, it's important for us to be able to see it from many locations. What the planes are doing right now is they're providing hundreds of observations that provide an important context to those longer-term observations that can only see the most important variables, but not necessarily all of the ones that are affecting change over time.